Hare Krishna. Can you all hear me?
Yes, ma'am.
Okay, so today I'll start with upthrust. So upthrust in fluids, Archimedes principle and flotation. Out of this flotation, you have studied in class 8 also. So today we will learn what is upthrust or what is the buoyancy. Now, if at all you remember, when you generally which we people do, like we try to insert the mug in bucket filled with water upside down. You try to insert the mug upside down in the bucket. Are you able to put it down, put it inside? Exactly upright mug, you want to put it inside water. Can you put it?
No, ma'am.
If you don't tilt it, you are not able to put it, and you can experience a force coming from the liquid. Okay, so I will request everybody to switch on the camera, please. So similarly, when you try to immerse any object inside water, you feel there is a resistive force from water on the body. So this upward force, which is experienced when a body is partially or wholly immersed in liquid, is called upthrust. So take a tennis ball, not the tennis ball, the ping pong ball, small plastic ball, and that generally floats on water. So you try and put your finger and try to put it down. So as soon as you put it down, you leave it, it will come back up. So why it comes back up? Why? Because there is an upward force. And this upward force, which is acting on the body, when does it act? When the body is in water, whether it is partially immersed or wholly immersed. So when it is in water or any liquid, so this upthrust is called, the force which is acting in upward direction is called upthrust, and it is denoted by FB, subscript B. So the upward force exerted on a body by a fluid in which it is submerged is called upthrust or the buoyant force. The property of the liquid to exert an upward force on the body in liquid is called buoyancy. The property is called buoyancy. The force is called buoyant force or upthrust. Even you fill the mug in with water and leave it inside the water level and try and pull it up till it comes to the surface of the water. The mug appears very light. As soon as you bring it out of the water, you feel it heavy. This is why you feel it light. That is also because of the upward force. Okay, because of the upward force, there is a supporting force in the upward direction, and so you feel that the mug is light, even though it is filled with water. Okay, so is this upthrust clear to everyone? What is upthrust?
A force that any liquid exerts on a body which is kept on it.
When a body is immersed in any liquid, then the force exerted by the liquid on the body is called upthrust. And there's always an upward force. It is always an upward force. It's not a downward force. Okay. And this property of the liquid to exert the upthrust is called buoyancy. So pushing an empty can in water, so you feel that there is an upthrust. Then pushing of cork in water, so you can make out there is an upward force. So just like liquids exert force, gases also exert force because that is also a fluid. So gases also have a buoyancy of fluid. So there is one question now. You have a helium balloon and you let that helium balloon loose. So it starts moving up. So why it starts moving up? Why it starts moving up?
Ma'am, because it is filled with helium and the density of helium is less than the density of the air around it.
Correct. The density of helium is less than the density of air around it. So it moves up. So the upward force is more than the weight of the balloon. So it moves up. So will it go indefinitely to a long, long distance and keep on going up? Will it keep on going up and
Ma'am,
up?
it will pop in some time.
Why? Let me see how many of you remember why it will pop up. Think why.
Ma'am, atmospheric pressure.
Atmospheric pressure increases or decreases?
Ma'am, it decreases.
So when the pressure decreases, volume of the body or object, volume of gas increases. So the volume inside will increase. It will surpass the elasticity of the balloon and the balloon will burst. And also as we go up, the air becomes thinner and thinner. So when the air becomes thinner and thinner, the upward force also decreases. So this balloon will not rise to an unlimited height. It will go to a certain height and then it will stop. Either it will stop, it will stay there for some time, or else it will burst. So when the whole reason behind a balloon moves upward is because of the upthrust. The upthrust exerted on balloon is more than the weight of the balloon. Okay, so upthrust exerted on the balloon is more than the weight of the balloon, and hence it will move upward. So that is the consequence of upthrust. So upthrust is experienced in fluids. So in fluids, matlab in liquid as well as in gases. Now, we know that weight is measured by beam balance, correct? Weight
Yes, ma'am.
is measured by beam balance. So I take 1 kg of cotton bale, 1 kg of cotton bale, which is little big, fluffy cotton, and 1 kg of iron. Mass is same, 1 kg, 1 kg. And I try to measure it with a beam balance. Will they both measure same 1 kgf, 1 kgf, or there will be a difference?
No, ma'am, there will be difference in the weight.
Which one will weigh more and which one will weigh less?
Ma'am, the iron will weight more than the cloud.
Why?
Ma'am, because I think the density of the cotton candy will be less, and the density of the iron will be more. That is why the weight of.
That is correct. So actually what happens? Iron will weigh 1 kgf, but cotton bale, its volume is huge. So when volume is more, there's more upthrust acting on it. So when there is more upthrust acting on it, so that downward force is 1 kgf and there is some force upward. So then balance force will be less than 1 kgf. So the balance force will be less than 1 kgf. So in simple language, because of the upthrust, a bale of cotton will weigh less and the iron ball will weigh the same, that is 1 kgf. Is this clear to everyone?
Yes, ma'am.
Okay. Now,
Excuse me, ma'am.
yes.
Ma'am, can you please explain the concept of upthrust acting on the object?
So upthrust, why upthrust is acting on the object?
No, ma'am, you said that upthrust acts more on this on the heavy denser object.
Yes, no, the upthrust will be more on if there is more volume, and upthrust will be less if the volume is less. So upthrust depends upon the volume. So that we are going to discuss very soon. Why upthrust depends upon the volume. Upthrust does not depend upon the upthrust does not depend upon the only the height. Just like pressure depends on the height of the liquid column, upthrust depends upon the volume of the liquid column. Okay, so we will be discussing this. Now, conditions for a body to float or sink in a fluid. It is very simple. There are two forces acting on a body when it is immersed. So one force is acting downward. What force is that which acts downward?
Ma'am, can I say?
Yes,
Wait.
correct. So weight of the object will act downward, and then there is an upward force. What is that upward force when it is kept in liquid?
Ma'am, can I say?
Yes,
Ma'am, buoyant force.
buoyant force. So, a very simple logic. If the buoyant force is equal to the weight of the object will float. Correct. If the buoyant force is more than the weight of the object will float. But if the buoyant force is less than the weight of the object will sink. Correct? So weight of the body, W, acts vertically down, and then there is a upward force, that is the upthrust or the buoyant force, which acts vertically upward, and we have to see the algebraic sum. If weight of the object is more, then the body will move downwards and it will sink. If the upthrust is more, the body will move upwards and will float. And if upthrust and the weight of the object is exactly the same, then the body will stay submerged in liquid, but it will not sink. It will keep floating underneath the liquid. So if the buoyant force is more than the weight of the body floats. So buoyant force is equal to the weight of the body floats but fully submerged. And if the buoyant force is less than the weight of the body sinks. So unit of upthrust is same as the unit of force, that is Newton or kilogram force. So far, any doubt?
No, ma'am.
What about others? Ayan, Rudra.
No, ma'am.
Janvi. Janvi, are you there? Janvi, are you there?
Ma'am, did you call for me? Actually, I went to washroom.
So did you understand till now whatever we had done?
Yes, ma'am. The upthrust and the buoyant force, yes, ma'am.
Okay. Janvi?
Yes, ma'am.
Okay. Now the characteristic properties of upthrust. Now this is Ashi, what you were asking me. So what is how upthrust acts? This is very important. So how upthrust acts? Okay. So just see this cylinder. Okay. If this cylinder is kept in water, in a fluid, so there is a pressure acting on the top surface and there is a pressure acting on the bottom surface. Now, which pressure will be more at the top or at the bottom?
At the top.
Why? Why?
Ma'am, I think the atmospheric pressure is also coming. So due to that, it must be
Ma'am, the pressure will be more at the bottom.
Pressure will be more at bottom. Why?
Ma'am, because ma'am, I know, but I'm not able to explain why.
is the liquid column here. Let us say it is H1.
Ma'am, can I try now?
Yes.
Ma'am, because the deeper we go, the weight of the water, like
Yes,
it, yes.
and the pressure increases. Pressure increases with the depth. Very simple thing. Pressure in a fluid increases with the depth. So pressure acting at this, and pressure acts in all direction. The pressure acting in all direction is the same at one point. So at this point, the pressure will be more than compared to this point because of the depth of the liquid is more. So the difference in the pressure is the upthrust. The difference in the pressure acting at the two surfaces is upthrust. Okay, so what is pressure at P2, B, H2 rho G2. So the difference is H1 into H1 minus H2 minus H1. So then pressure is equal to, the pressure will be equal to H2, that is, let it be X. This height be X. So X into rho into G. So that is the pressure. Now what is force? What is force? Anybody can say what is force? Oh, what is force?
Ma'am, can I say?
In terms of pressure. What is force in terms of pressure?
Ma'am, force is equals to a pressure upon area.
Pressure upon area. Pressure into area. Pressure is equal to force upon area. So force is equal to pressure into area. How can you people forget this? Pressure is equal to force upon area. So force is equal to pressure into area. And pressure is this. So what do we have? X into rho into G into A. So A into X, area of cross section into height becomes the volume. So pressure, force is equal to V rho G. So force is equal to V rho G. Force is equal to V rho G. So that force is the upthrust or the buoyant force. So from here, if the volume of the liquid, volume of the body is bigger, is larger, then the upthrust will be larger. If the density of the liquid is larger, the upthrust is larger. Here we can say for volume, we can also say that if the volume of the liquid displaced is larger, then the upthrust is larger. And if the volume or if the density of the liquid in which the body is submerged is larger, then the upthrust will be larger. So upthrust will be more in seawater as compared to river water because density of seawater is high. Okay, so upthrust acting on a ship is more than the upthrust acting on the needle, and therefore ship can float and needle sinks. Needle sinks. Is this part clear? This is very important. You are asked the reason for the upthrust and then what is upthrust, what is the reason for the upthrust, and how do you derive the formula upthrust is equal to V rho G. What is upthrust?
Ma'am, can I say?
So why everybody's video is off?
Ma'am, today there's a network issue in my area. The network tower caught fire. That's why.
Okay, what about the others?
Ma'am, I'm out of station, so I can't turn on my video.
What happened?
Ma'am, I'm out of station.
Okay. So till now we studied what is upthrust. Rudra, what is upthrust? What is upthrust?
Actually, ma'am, your video was stopping in between, so I don't know.
Why didn't you ask? Why didn't you ask me? What is upthrust? When I'm constantly saying,
Ma'am, maybe in the force applied in upward direction.
by whom?
Ma'am, by liquid.
Yes. Janvi, can you tell me clearly what is upthrust?
Upthrust is the upward force exerted on a body um, in which the fluid is submerged.
In which upthrust is the upward force acting on a body. Yes. By
The fluid in which it is submerged.
by the fluid in which it is submerged. Okay. So it is an upward force, and this tendency of applying the upward force is called buoyancy. Now, how does this upward force act? So we know that there is a difference in the pressure at the upper layer of an object and at the bottom layer of the object. So the difference in the liquid pressure acting at the top part and at the bottom part is the cause for the upthrust. And since upthrust is the force, we know that force is equal to pressure upon pressure into area. So upthrust becomes pressure, difference in the pressure into the area. And difference in pressure is H rho G, and H rho G into area. So H into area will become volume, because we know that V is equal to height into the area of cross section. So H rho G becomes V rho G. Okay, when you multiply with area of cross section. So now we have V rho G. So more is the volume displaced, the more is the upthrust, the more is the density of the liquid, the more is the upthrust. More is the volume of the liquid displaced, the more is the upthrust, more is the density of the liquid, more is the upthrust. Quickly go through whatever I have taught. I'll be back in 5 minutes. Quickly go through. So is it clear whatever we studied? Children,
Yes, ma'am.
Janvi, what are the factors which affect the upthrust? What are the factors which affect the upthrust?
Ma'am, can I try?
Yeah.
Ma'am, density of the liquid and the body.
Density of the liquid and the volume of the liquid displaced by the body. Okay. Volume
Okay.
stands for volume of the liquid displaced by the body. So there are two factors, volume of the body submerged or the volume of the fluid displaced, and the density of the fluid in which the body is submerged. The effect of the upthrust is that the weight of the body immersed in the liquid appears to be less than the actual weight. So the actual weight, when you take the weight of the body in air, suppose it is 100 Newton. So if you weigh it in water, inside the water, it will be less than 100 Newton. And how much less will depend upon the volume of the water displaced. Okay, that depends upon the volume of the water displaced. Okay, so when we pull the bucket filled with water, if you pull it out, so till it reaches the water surface, it appears to be very light. As soon as it comes out of the water surface, suddenly you feel the weight. This is because till it is inside the water level, it experiences an upthrust. And because of the upthrust, the weight appears to be less. Okay, because upthrust is upward force and weight of the body is downward force. So we get the algebraic sum. Janvi, is this clear?
Yes, ma'am.
Ayan?
Yes, ma'am.
Okay. So a body weighed by sensitive spring balance will weigh slightly less in air than in vacuum because of the upthrust of air on the body. We have to take a very sensitive balance, beam balance, spring balance. Okay, now Archimedes principle. Archimedes principle states that when a body is immersed partially or wholly in liquid, it experiences an upthrust which is equal to the weight of the liquid displaced. कुछ नहीं, सेम प्रोसेस जो अपथ्रस्ट का हमने पॉइंट बोला था, अपथ्रस्ट FB इज इक्वल टू V rho G. V मतलब वॉल्यूम, रो मतलब डेंसिटी. वॉल्यूम इंटू डेंसिटी विल गिव यू व्हाट? Yes, Ashi, volume into density gives us?
Pressure.
Volume into density, how can you get pressure? Ayan?
Yes, ma'am, I'm telling you. Ma'am, volume into density.
Rudra?
Ma'am, can I say?
Ma'am, equal to weight. Weight.
No.
Ma'am, can I say?
Yes, yeah.
Mass.
Yes.
Ma'am, can I try?
Yes.
Ma'am, mass.
Yes. Volume into density is mass. So volume into density is mass. Mass into gravity is? Mass into gravity क्या होता है?
Weight.
Weight. So we said that. Let me share. So just now we said that upthrust is equal to V rho G. So V into rho is mass, mass into G is weight. So upthrust is equal to weight. Weight of what? Weight of the liquid displaced. Is this clear?
Yes, ma'am.
Yes, ma'am.
Ashi?
Yes, ma'am, it is clear.
Okay, so Archimedes principle क्या बोलता है? Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. Okay, so Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust, and this upthrust is equal to weight of the liquid displaced. So that is equal to V rho G. So more is the volume of the liquid displaced, more will be the upthrust, more is the density of the liquid in which the body is submerged, the more is the upthrust. Okay.
Yes, ma'am.
So bodies of density greater than that of the liquid will sink in it, and the bodies of density, average density equal to the or smaller than the liquid will float in it. The solid bodies with density rho greater than the density of the water will definitely sink because weight of the object, see, weight of object. What is weight of object? Volume of the object into the density of the object into G. That is the weight. Everybody agrees?
Yes, ma'am.
Now, what is the upthrust? Upthrust on the object is equal to, again, volume of the liquid displaced. That is, if it is completely submerged, we see the density of liquid into G. So if this is getting cancelled. So if rho solid is more than rho liquid, then weight will be more than upthrust. When weight is more than upthrust, the body sinks. And when upthrust is more, then the body floats. Clear?
Yes, ma'am.
So the average density of a body is more than the density of water or the liquid in which it is submerged, it will sink. If the average density of a body is equal to the average density of the liquid in which it is submerged, it will stay inside the water everywhere, but it will stay floating. And if it is less, it will come up and float with the partially submerged. So the average density of a hollow body is the ratio of mass of the body plus the mass of air enclosed to its total volume. Empty tin can float on water because its average density is less than the density of the water. Average density matlab kya ho gaya? Density of the object plus the density of the water inside it or air inside it. So the average density is less. Anything, any doubt in this part? This is very important part. Now, upthrust always acts in the upward direction, and it acts from a point that is called the center of buoyancy, and the weight of the object acts from a point which is called the center of gravity. So weight of an object acts from the center of gravity, and the upthrust acts from the center of buoyancy. If the body is completely submerged, then the center of gravity and the center of buoyancy is same. But if the body is not completely submerged, then there is the center of gravity and the center of buoyancy differs. And in that case, the body is stable only when the center of gravity and the center of buoyancy are in the same line. They are in the same line, then the body is stable. आप cork को देखोगे, आप जैसे उसको submerge करोगे, it will adjust its position. It will adjust its position and then become stable. So when it adjusts its position, that means what? The center of buoyancy and the center of gravity, they fall in the same straight line. They fall in the same straight line. So reason for the upthrust, we did the reason for the upthrust, the difference in the pressure at the top surface of the body and at the bottom surface of the body is the difference for the upthrust. Now tell me one thing, what will happen to a thin lamina? Is there any difference in the pressure on the top and the bottom of a thin lamina?
Ma'am, what is the meaning of lamina?
Okay, thin lamina मतलब thin sheet. एक iron tin का sheet लिया हमने, उसको पानी में डालेंगे. So will that sink or will that float?
Ma'am, it will float.
It depends upon the density. If
Which density?
its weight, if its weight is much more than the
Ma'am,
weight,
the surface area of the sheet is big. That's why
Surface area
the
is
pressure distributed on the liquid spreads. Look, it spreads over the sheet.
how much is the difference between the upward top pressure at the top surface and pressure at the bottom surface of the lamina?
what is the difference between?
The pressure at the top surface and pressure at the bottom surface of a lamina. This is P1 and this is P2. A lamina means a thin sheet. So is there any difference of pressure acting at the top surface and at the bottom surface?
Ma'am, the bottom surface will experience the buoyant force.
No, that is okay. We'll experience the buoyant force. I'm talking the liquid pressure at the top surface of the lamina and at the bottom surface of the lamina will be different or remain the same.
Ma'am,
Ma'am, they will be different.
Why? Why different?
Ma'am, it will be same in my sense because you only said that the pressure is same at all the sides, but pressure the downward is more, but I think it will be same at all sides.
It will be same. Why it will be same? Because the lamina is thin. It is very thin lamina. Upward height and lower downward height में कोई difference ही नहीं है ना. It's a thin sheet. एक thin sheet है. अब ये thin sheet है, ये P1 है और नीचे की तरफ जो है ये P2 है. So P1 and P2 में difference क्या है? H, rho, G. So H क्या है? H तो बहुत छोटा सा है. Minimum 0.01 centimeter. अगर इतना thin है, so there is no difference in the height, and so there is no difference in the pressure. So pressure P1 is equal to pressure P2. So when pressure is same, that means force is also same. Force acting on the top of the lamina and at the bottom of the lamina is same. And so what will happen? There is no difference. And so the weight of the so there is no upthrust. And so weight will act it downwards. And when it acts downwards, then the body sinks. So a thin lamina, it always sink. A thin lamina will always sink. Understood?
Yes, ma'am.
Why it will sink? Because since it is very thin, there is no difference in the pressure of the fluid acting at the top surface of the lamina and the bottom surface of the lamina, and hence the upthrust is less than the weight of the object. because upthrust is almost zero. So upthrust is zero, and so weight of the object will sit down. Clear?
Yes, ma'am.
Yes, ma'am.
So if a lamina is immersed in liquid, the pressure on both the surfaces will be nearly the same, and so the liquid will exert negligible upthrust on it, causing it to sink into the liquid due to its own weight. Due to its own weight. So let us take an example. Let us take an example. The entire body, which you see, is 500 cc. Okay, the entire body is 500 cc, and the density of the solid is given 0.07 gram per centimeter cube. So the mass of this object is 500 into 7, so it becomes 350 gram force. Now, volume of water displaced is 500 cc. So that means weight of the liquid displaced is 500 gram force. So now upthrust is 500 gram force and the weight of the object is 350 gram force. So now what will happen? Will the object completely sink in water or will partially remain out or will be inside water fully?
Now, what is a CC?
As cubic centimeter or centimeter cube.
Okay, ma'am.
Ma'am, 350 GF is the weight, right?
This is the weight of the object.
When the weight and the pressure, if the pressure and they are same, then it will float.
The upthrust, not the pressure.
Upthrust and the weight is same, then it will float. Ma'am, am I right?
What you're saying, weight and the?
Ma'am, upthrust is 350 GF, right?
Yes.
Ma'am, then it will float because the weight and upthrust is same.
Weight of the object is 350 and it is displacing 500 cc. That means the upthrust is 500 gram force.
Ma'am, it will not entirely sink,
Okay.
but
So
it
what will happen
flow.
is that it will float, but it will be partially submerged. उतना ही सबमर्ज करेगा जितना कि 350 cc को 350 gram force को support कर सके. So for a floating body, the weight of the body is equal to the upthrust, and so the apparent weight of the body of a floating body is always zero. अगर हम apparent weight लेंगे floating body का, that will be always zero. अब फिर से समझो इस बात को. So this is an object and इसका weight, let's say इसका weight is 400 gram force and इसका volume is equal to 200 gram force. Okay, sorry, volume is equal to 200 centimeter cube. 200 centimeter cube. Let us take the weight has to be 100 grams. So weight of the object is 100 gram force and volume is 200 centimeter cube. So अगर मैंने इसको पानी में डाला, so it upthrust acting FB will be equal to 200 into 1, correct? That is equal to 200 gram force. So when 200 gram force is acting but the weight of the object is only 100 gram force, तो क्या करेगा ये liquid इसको ऊपर push कर देगा. So it will now float like this. So almost half of the liquid will be inside water, and that will be equal to the upthrust acting on the body.
Ma'am, so it means that it will float equally, right?
It will float partially submerged.
Okay.
Partially submerged. पूरा पानी के अंदर नहीं रहेगा. But अगर weight of the object, if the weight of the object was 100 gram force and volume was also 100 cc, और उसको अगर हम पानी में डालते, so upthrust would have been also 100 gram force. So in that condition, what will happen is that आपने पानी के अंदर जहां पे भी छोड़ा उस ऑब्जेक्ट को, वो उधर ही पड़ा रहेगा. वो उधर ही पड़ा रहेगा. So in this case, the upthrust is equal to weight of the object. Okay.
Yes, ma'am.
So if a body is completely submerged in liquid, the volume of the liquid displaced will be equal to its own volume and the upthrust will be maximum. So although the above result is derived by cylindrical body, it is equally true for any shape of the body. So when a body is in fluid, there are two forces acting on it. The force which is equal to its weight, that is downward force, and the buoyant force, that is upward force. So according to the principle of flotation, the weight of a floating body is equal to the weight of the liquid displaced by the submerged part. So weight of the floating body is equal to weight of the liquid displaced. So that is equal to W is equal to FP, and that is equal to buoyant force. Apparent weight of the floating body, weight of the body, then you take the weight when it is submerged in liquid. So you get the apparent weight is equal to true weight minus upthrust. True weight minus upthrust, that is the apparent weight. Now upthrust is equal to the weight of the liquid displaced. ये हमने किया. I have explained you. So larger the volume of the submerged part, the greater is the upthrust. But the same volume inside the fluid, the more is the density of the fluid, the more is the upthrust. Upthrust acts on the body in upward direction and from the center of buoyancy, and the weight acts from the center of gravity. And they both should be in same line in order to body have a stable equilibrium. So volume of the body submerged in a liquid and density of the liquid in which the body is submerged are the two factors. The effect of upthrust is that when the weight of the body immersed in a liquid appears to be less than the actual weight, So all the girls will try to take the weight inside any liquid so that there is an upthrust acting on it and its weight is less and the weight of the body is less. Okay. It can be 0 for some. So a ship floats while a needle sinks, same thing. The weight of the ship is more than the weight of the solid. So force acting, the upward force or the buoyant force acting on ship is more, and so it makes the ship to float. We did Archimedes' principle. So when a body is partially or wholly immersed in a liquid, it experiences an upthrust, which is equal to the weight of the liquid displaced. So upthrust is equal to weight of the liquid displaced, that is equal to actual weight minus apparent weight. Solids with greater density than the liquid will definitely sink, and liquids with greater density than the solids will always sink. So a body of density greater than the liquid, that of the liquid will sink, and then average density of the body is less than that of the liquid, it will float. So this we did all of this. Okay, let me stop and show you this video.